A major asteroid is on its way to hitting Earth. I'm here with a local scientist by the name of Jacob Meza, also known as Dr. Drake. Take it away.
So thank you, Oscar. So what we're going to be talking about right now is the asteroid Iridium, as you all know. So we're going to be talking about details about Iridium right now. So what we know about Iridium is that it's 1,560 kilometers at its thickest point and 936 kilometers at its thinnest point. We know that Iridium is located 104.7 million kilometers away from Earth and 84 million kilometers from the edge of the asteroid belt. Iridium is moving at 103,450 kilometers an hour relative to Earth. It is expected to arrive at Earth January 19. So Iridium's shape resembles a deformed bone, and it's currently being tracked by NASA as it does qualify for the NASA tracking, qualifications of 460 feet or 140 kilometers in size.
So was there any asteroids recent?
Yeah, so there's actually one in Russia back in 2013. The asteroid was about 20 meters or 666 feet actually. The asteroid was responsible for sending 1,200 people to the hospital and shook and broke glasses and people within a 50-mile radius. And there was no warning before the asteroid hit.
Was there any evidence that an asteroid hit 65 million years ago?
Yes, there was. So there are 5 pieces of evidence. So one of them was the iridium. So this iridium is an element that's only found in asteroids. So that supports the theory about the asteroid hitting 65 million years ago. Because if an asteroid were to hit, and all the debris that would be spread from that, it does make sense that the iridium from that asteroid would be spread throughout Earth. Another piece of evidence is the soot or ash that was found in the fossil records that date back 65 million years ago. In those fossil records, we found that there was a lot of iridium, so much iridium that it would account for all the world's forests burning down. So what that means is that such an asteroid could have caused such a large fire that caused the asteroids to burn down. Also, the fossil records show that there was massive climate changes which ended up contributing to the 5 mass extinctions, and changes in plant and animal biodiversity show that 65 million years ago, more than 50% of the animal species disappeared, which supports the theory that the asteroid that killed most life on Earth back then does exist. That's why it is important to stop Iridium, because an asteroid of its size can do the same to us.
So why is this asteroid very important?
Yeah, so it does connect to Newton's laws of motion, which the first one is Iridium has a lot of inertia. This is because the first law of motion refers to if an object has more mass, it has more inertia. So Iridium is a big asteroid, so it does have a lot of mass, which means it has a lot of inertia, which means it will have a lot of power when it comes towards Earth, and it definitely won't be good when it hits us. So the second law of motion refers to how force equals mass times acceleration. And since we talked previously, Iridium has a lot of mass, and since its speed is 103,450 kilometers an hour, its speed combined with its mass will definitely have a lot of impact on its force when it hits on Earth, which won't be good for us.
And what about the third law of motion?
So if Earth were to get hit by Iridium, it wouldn't be good, because Newton's third law of motion says that for every action there's an equal or opposite reaction. So if an asteroid were to hit Earth, it wouldn't react very pleasantly, and most likely we would all die.
And what about the laws of gravitation?
So the laws of gravitation support that when Iridium gets close enough to Earth, it will begin to pull Iridium towards us. So that's why it's important to stop Iridium from getting that close, so we won't have to worry about it, because if it gets too close to Earth, then there won't be much we can do about it. And now we're going to show a simulation of how we're planning on stopping Iridium from our top tier scientists in NASA.
Okay, so as you can see here, we have a simplified diagram of Earth orbiting the Sun. And the yellow dot represents the Sun, the blue dot represents Earth, and the gray dot represents Iridium. So if you look closely, you can see these little red dots on Idiom. So what that represents is rockets. So what the plan is that we are going to attach rockets onto Idiom and hopefully push it off its course, so that way we move it towards the sun, and the sun's strong orbit pulls it towards the sun, and then it melts Idiom. So how it's gonna go is a little something like this. So the rockets begin to push Idiom off its course, and then once it gets close enough to the sun should be pulling it into orbit. And once it reaches close enough, it will melt within the sun's intense heat. So that way, we move it as far away from Earth and get rid of Idiom without any catastrophic dangers. So now, a lot of questions was why we don't just use a bomb and blow Idiom up. Well, that's because we don't know where the fragments of the explosive Idiom is gonna go, so if we blow up Idiom with a huge bomb, it could lead to big problems, because then we could have a meteor shower raining down from all the shards of Idiom that rains down on Earth. So that's why it's best just to get rid of Idiom as a...
Thank you guys for watching my video.
Yes, thank you all for watching our video, and we hope our plans and efforts succeed to stop the Idiom.